Hey, it's Coach Latham again, and we're gearing up for the Algebra 1 SOL test, and we want to do a quick review on functions. As always, this is not a complete study of functions. It's just a quick review to jog your memory before the test. Listen to it the first time you go through, then turn down the volume. Try to go through it again without listening to me and see if all the answers are ready for you to use. First one, we have a function that we want to find f of some number. What that simply means is in place of x, we're going to substitute in -2. So we're going to put -2 in place of this x right here. So it's going to be 2 times -2 plus 1. And when you work that out, you're going to get -3. This one is done the exact same way. Notice the absolute value sign right here. And we're going to put -5 in place of x. We're going to put -5 in place of x in parentheses. That's always a good idea whenever this is a negative number, especially when it's raised to an exponent. But we'll put it in. You can certainly do all of this on your calculator in one step, or you could work it out step by step, but the answer will be 124. Sometimes they'll give you the question like this, where they'll give you the domain, and the domain is the set of x coordinates, and you're asked to find the range, which is the answers to those, or f of x or y. So what we're going to do is take -3, put it in place of x. Again, remember it goes in parentheses. 0 in place of x, 3 in place of x, and 5 in place of x. We have them all worked out for you right here. You'll see that the four answers are 9, 0, 9, and 25. Now, in the domain or the range, you don't write duplicate numbers. So we'll just eliminate that 9 there and say the solution to that is 0, 9, and 25. This one is a data table, and you're asked to tell whether or not this is a function. And if it is a function, then name the domain and the range. Well, the test to see if it's a function is to see if any of the x's repeat. We look down the x column, 0, 1, 2, 3, 4. None of them repeat, so it is a function. The domain is going to be the x terms, 0, 1, 2, 3, 4, and the range is going to be the y terms, 5, 6, and 7. Remember, we don't write duplicates, so we'll just say 5, 6, and 7 instead of 5, 5, 6, 6, 7. Same question here for another data table. Determine whether or not it's a function. Look down the x column, 0, 1, 1. Oh, can't repeat x's and still be a function, so this one is not a function. Right here, we've got a nifty question that was on the SOL test a couple years ago. It tells you to tell which one of these numbers here we could replace x with to make a function. Well, since the x's can't repeat, 3, 4, 5, this other number right over here can be anything except for 3, 4, or 5. The only option down here is D, 6. You could put a 6 in there and it would still be a function. Sometimes you'll get the graphs and you'll be asked to determine which of the following is not a function. Well, one of these is not a function, and the way we test it on a graph is by using the vertical line test. Notice how I've drawn a vertical line here and I've hit this curve twice. That means that it's not a function. The next question says which one is a function. That means 3 of them are not. And the 3 that are not are the ones that I can draw vertical lines through and hit it more than once. Now this one down here, there's nowhere I can draw a vertical line and hit it more than once. So the one on the bottom left is a function. This one is done a similar way. We've got a set of data points on a graph, and we want to determine whether or not they represent a function. These data points do not represent a function because we got one right on top of the other. And I could draw a vertical line through there and hit these 2 dots in one swoop. So this one is not going to be a function. Here's another set of data points, and since we don't have any points on top of each other, this one does represent a function. And we can find the domain and the range if we wanted to. And the domain are going to be the x values for these points, so I could just count from left to right. I've got a point at -4, I've got a point at -3, I've got a point at -1, I've got a point at 2, I've got a point at 4. So that's going to give me my domain, -4, -3, 1, 2, 4. I do the same thing for the range, except I'm going from the bottom to the top. I've got a point at -2. I've got 2 points at 2, but I only write it once. I've got a point at 4, and I've got a point at 6. So the domain are all the x values for those points, and the range are all the y values for those points. I want to find the domain and range for this line segment. Now, I do it the same way. I'm thinking about my x's when I'm thinking about the domain. The domain goes as far to the left as -5 and as far to the right as 5. So it goes from -5 to 5. I put the x in the middle. I fill in with less thans, and then I determine whether or not the equal sign goes under it. Solid dots means that they're equal. So the domain is going to go from -5 to 5, including both -5 and 5, and this is how we write it. We do the same thing with the range. The low end of the range goes as low as 2. The high end of the range goes up to 7. So y is going to be between 2 and 7. Solid dots means I put less than or equal to in. This one I have an open dot and a solid dot. I still do it the same way. The only thing that will change are my symbols. But for the domain, it goes as far to the left as -5 and goes as far to the right as 6. So it goes from -5 to 6. I have a solid dot here, so the 6 is included in the answer. That's why I have the equal part there. I have an open dot here. That's why it's just less than. I do the same thing with the range. The range goes as low as 1 and as high as 5, so the range goes from 1 to 5. This is included in the answer, but I've got an open dot up here at the 5, so it's just a less than there. I've got one more here. This is an arrow on the end. I hope that shows up. So when we're figuring this one out, the domain goes as far to the left as -5, but it's going to go on forever to the right because of the arrow. So it goes as far to the left as -5. It goes to infinity because it keeps going forever. A solid dot over here makes this less than or equal to, and since you can never get to infinity, that's just going to be less than. We do the same thing with the range. It goes as low as -3, but it will keep going up forever as well. So it goes to infinity. We have a solid dot at -3 that makes the equal part. And since you can never get to infinity, it's just a straight less than. Direct and inverse variation. We have time to squeeze those in here. You have to tell me which graph represents a direct variation. A direct variation is an equation that's in the form y equals kx. Y equals kx, where k is really the slope in disguise. And since there's no number on the end, the y-intercept always has to be 0. So the only one that goes through the origin is this one, and that's a linear equation. So this one is in the form y equals kx. There is no y-intercept aside from the 0, and k is 1. Which of the following is the equation for a direct variation? Well, we just said it has to be in the form y equals kx, so it has to be d. That's going to be a straight line that passes through the origin. We can get a data table, and they can ask you for the one that depicts a direct variation. Since it always has to be y equals kx and go through the origin, we're looking for the one where every x is multiplied by the same number to get to y. The one that works is this table down here because every x is multiplied by 5. Try this one. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. 0 times 5 is 5. So this is the direct variation, y equals 5x. None of these others work that way. You can't multiply by the same number in each table. Now we need to talk about inverse variation, which is kind of the opposite of direct variation. But inverse variation is where x times y is equal to a number. This is kind of a tricky question I started with here. It says, which of the following equations does not represent an inverse variation? Well, A is the one that is not an inverse variation because it's direct variation. And then the point here is that B, C, and D are all three the same equation. XY equals 10 is kind of your standard inverse variation, but if you solved it for y and divided both sides by x, y is equal to 10 over x. If you solved it for x and divided both sides by y, x equals 10 over y. So B, C, and D are really the same three equations. Which table depicts data that forms an inverse variation? Remember, inverse variation, x times y, has to be the same thing. And the one that works is the one on the bottom left. 10 times 1 is 10, 5 times 2 is 10, 2 times 5 is 10, 5 times 2 is 10. The equation for this table is x times y equals 10. This is your form of inverse variation, and in this case, k is 10. What is the direct variation equation for the data table? So we know we're looking for y equals kx because it's direct variation. So the question is, what are we multiplying all of these by to get these? Well, negative 3 times 2 is negative 6. So B is going to be your answer. And this one says, what is the inverse variation equation for the data in the table? We know that's in the form x times y is equal to a number. So in this case, they all multiply to be equal to 2. 1 times 2 is 2, 2 times 1 is 2, even 0.5 times 4 is 2, and 4 times 0.5 is 2. So it's going to be xy equals 2. Last question we're going to look at. We have a problem to solve here based on direct variation. It says that Scooter's getting paid direct variation, that's an hourly rate, and when he works 18 hours, he gets paid $126. So you got to figure out how much is Scooter getting paid per hour. So the direct variation for that is going to be y equals kx. When he works 18 hours, he gets paid $126. So dividing both sides by 18, we find out that he's getting paid $7 an hour. That's not the final answer though, because it says, how much does he make if he works 23 hours? Well, now that we know that he gets paid $7 an hour, we just do 7 times 23, and so he gets paid $161. This has been a quick review. I do have a 15-minute video that explains more about direct and inverse variation, but this one is a good one to prime yourself for the SOL test. Remember, after this, go back and redo the video with the volume turned off and see if you can get all the answers on your own. Good luck, keep studying, and look for the other SOL test review videos.